Welcome. In this video, I will do one side limits. So I have this presentation which says a limit of f at x as x approaches c from right. So we present with that positive to present it's our limit from right, and I have a limit of f at x as x approaches c from left. So we present when you use that subscript negative to present our limit that is from left. So let's do some review. So if you see here, I have these figures, which is figure A, figure B, and if you see, I have a whole, which is the whole discontinuity here, and a jump discontinuity here. So if I can say this is my function f at x, and this one is also f at x, so what will be the limit of x at that discontinuity? So let's say this whole discontinuity is at c. What will be the limit of f at x at that part here? So if we come from this side, we say you come from the right, so we will be coming from right, so we'll have that positive. We'll approach our c with this positive here. So what will be the limit? The limit, if you say at c, the limit will be equal to L. And if we come from, let's say you approach our C from left, which represents that script negative, what will be our limit? And if you see, even if we come from this side, our limit will be still the same as L. So by saying that, you can then conclude that a limit of f as you approach, as x approaches c, it's equal to L, because a limit from right and the limit from left, they are equal to L. So this means that a limit of f at x as you approaches c, it's L. So what about this one, this B presentation here? So if you see, if I'm coming from this side, which is my right side, and I'm approaching, let's say you have our c in here, let's say this is our c here. So what will be the limit? So if you, as I'm approaching from this side, I will have to use this portion of f at x. So I will have to use this portion. So f at x is defined here at this portion of graph. So as I'm coming to see here, my f at x will be here, and as I'm coming, so I can then say here, let's say, let's name it as r here. So I can say that a limit of f at x as x approaches c from right, it's equal to r. What about when I'm approaching from left, when I'm coming from this side? So I will have to use this portion of graph. So I will approach c by this, by here, I will be here. When I'm approaching c, my f at x will be there. When I'm approaching c, here will be there. When I'm at c, my f at x will be there. So let's label it as x. So a limit of f at x as x approaches c from left, it will be equal to L. So if you notice now, L is not equal to R, so they are not equal. So our sides limits are not equal. Therefore, I can conclude that a limit of x as x approaches c of f at x does not exist. So I can conclude based on my left and right, on my side limits, which is left and right limits. So on my left and right, which is when I'm approaching from left and when I'm approaching from right, they are not equal. This means that a limit does not exist. So let's see an example. So if I have this function here, don't worry about what type of a function. It's just a function to demonstrate this one side limit. So if I can say first, let's say a limit of f at x as x approaches 2 from right. what will be the limit? So if I'm coming from this side to 2, what will be the limit? This means my f at x is defined here at this interval, which is 0 and 2. So which is 0 and 2. So my f at x is defined here. So when I'm there, my f at x will be there. When I'm here, my f at x will be. When I'm at 2, my f at x will also be 2. So I will have 2 here. My f at x will be 2. And then, but it's not defined f at x at 2. It's just the limit of f at x from right, which is defined as 2. So what will be the limit of f at x as x approaches 2 from left? So if I'm approaching 2 from this side, which is, I can say this was from infinity. So if I'm coming from this interval, which is 2 to infinity, so what will be the f at x here? So what will be the limit of f at x if I'm approaching from right? So if I'm coming from this side and I'm coming to 2, if you see, I will be using this portion of graph here. So I will have f at x here and f at x, no, and I will have f at x here and f at x here. If you see, as I'm approaching to, f at x also approaches to on my y-axis. So this means I will have 2 here. F at x will be equal to 2. So I can then conclude that a limit of f at x as x approaches to its 2 based on my side limits, which are equal to. But what about a limit of f at x as x approaches 4? What about a limit of f at x as x approaches 4? What will be equal to? So if you notice here, a limit of f at x as x approaches 4 from right, what will be equal to? And what will be the limit of f at x as x approaches 4? As x approaches 4 from left. And what will be the limit of f at x as x approaches 4? So let's look on our function. So if you see, when I'm coming from this side to 4, I will have to use that portion of the graph here up to here. And if you notice, as I'm approaching 4, my f at x will be equal to 4, which is I will have 4 here. And if I'm coming from this side, let's use another car. If I'm coming from this side to 4, I will have to use this portion of the graph here. And at this portion of the graph, if I'm approaching for f at x, the limit of f at x will be 3. So based on our side limits which are not equal, I can then conclude that f at x, the limit of f at x as x approaches 4 does not exist. Based on my side limit. So we use side limits to determine whether the limit exists or not. So that was it, guys. I hope you enjoy my video. If you did, please don't forget to subscribe, like and comment to my channel. Thank you. I will see you in the next video.